Okay, let's go ahead and take a look at chapter 5.4.9 and 5.4.13. This involves the idea of conditional probability in chapter 4, where we're looking at what's the probability of an event occurring given that we know another event has already occurred. And so we again talked about what does that mean in lecture. So let's look at an example. Let's first look at this idea of probability of an event happening given another event has already occurred is connected to this idea, are those events independent or dependent, right? So if they're related in some way, then of course the outcome of the occurrence of one affects the outcome of another. So we can answer questions like this on here, number 12, or 5.4, number 9. Are two events independent? So it's another way to think about it is by actually calculating probabilities. And so what we know from the definition from our notes is that two events are independent if the probability of one event given the other one occurred is just equal to the probability of that event. If they're equal to each other, that means F in this case has no influence over E. And so we would say those events are independent. And so in this case here, on this kind of basic example here, basic meaning it's just kind of simple, not that it's easy, but we have this situation where you have an event that someone earns more than $75,000, another event that earns a bachelor's degree, and are those two events independent or not? And so we can take a look at our definition. Here's E and here's F. What's the probability of E given that F occurred? That's 7.5%. Given that he's earned a bachelor's degree is 7.5%. What's the probability that someone earns more than 75%? It is earns more than 75,000. It's 7.5%. Since those two numbers are equal to each other, we would say those events are independent. And again, it's based off of this definition here. Looking at the next one here, it's using our definition for how do we actually calculate the probability of an event given another one occurs when we know the probabilities ahead of time, similar to this case here. So here's the setup here. The probability that a specific day is cloudy is 34%. The probability that it's cloudy and foggy is 31%. And so the question that's being asked is, what is the probability that an event is foggy given that it is cloudy, or day is foggy given that it's cloudy? So we're really calculating the probability F given E. And in this case, we have the formula from lecture. It's the probability E and F divided by the probability of E. So in this case, we know those values already. Probability of E and F is 0.31. The probability of E is 0.34. And so then you just divide those two numbers there, 0.31 divided by 0.34, and I get 0.9117. 0.91, let's get back, 3 decimals, 912. So 91% chance that a day would be foggy given that we know it's a cloudy day.